This is exercise 13.1, question number 4. A cubical box of 7 centimeter is surmounted by a hemisphere. It means that hemisphere is there on the top of a cubical box. What is the greatest diameter of the hemisphere? That we need to find out. Find the surface area of the solid. Let us see the figure. See, here I have shown you the top view. On the cubical box, the hemisphere is there. Okay, this one. And this one top view I have shown in 2D figure. So this portion you are able to touch, but this portion you cannot able to touch, this circular portion. Why? Because this is intact with the cubical box. So only these 4 corners you are able to touch. Right. Now look at this figure here. The figure which you are going to draw in your notebook is this one and this one. Okay. This is just to make you understand. Now here I need to find out. First they said what is the diameter of the hemisphere. Now see here, from here to here the diameter will be there. That means it is nothing but side of the cube only. So diameter of the sphere will be 7 centimeter. Correct. Now they told you to find out the surface area of the solid. I said surface area means the area where you are able to touch. Obviously, other 5 surfaces of the cubical box, they are square. So 5a square will be the area of them. But what about the top? The top will look like this. See, this way. So these 4 corners are there. If I want to find out area of these 4 corners, what I will do? From the area of the square, I will remove this circle. Correct? Area of square minus area of the circle. So I'll get the area of these 4 corners. Okay. So let us write it down now properly. First I'll write down diameter of the hemisphere, the greatest diameter of a hemisphere is equal to 7 centimeter. Okay. Now side of square, I'll write it down side as A, side of square which is equal to A, which is equal to 7 centimeter. You can say square, you can say cube. The side will be 7 only, it will remain same. And R is equal to radius of the hemisphere, which is equal to 7 by 2 centimeter. All those things we have written. Now we need to find out what? The surface area of solid. So I'll write it down here. Surface area of solid, which is equal to, see, I said for the cubical block that 5 surfaces are the squares. So here 5a square plus area of the square. That means a square minus area of the circle, pi r square. Now another surface which you are going to touch is what? The hemispherical portion. Just look at the figure once again. This hemispherical portion also you are able to touch now. This one. So csa of the hemisphere. So here I'll write it down. csa of hemisphere, which is nothing but 2 pi r square. I will just open the bracket. 5a square plus a square minus pi r square plus 2 pi r square. Look here, 5a square and a square became 6a square. This one and this one is minus, one is plus. So 2 pi r square minus pi r square is nothing but pi r square. Now I'll substitute the values here. 6, side of the cube is 7, so 7 square plus pi means 22 by 7. And here radius is what? 7 by 2 I said. As it is a square, 7 by 2, 2 times we'll write it down. We'll show the cancellation. 7 and 7 got cancelled here. 2 ones are, and this is 11. So here 6 into 49 plus 77 by 2. Here 6 into 49 will be 6 nines are 54. So 4 is here, 5 carries, 6 fours are 24 and 5, 29 plus this is 38.5, which is equal to 332.5 centimeter square. Right? I hope all of you understood this sum. Thanks.